Okay, I should be back online with a public stream setup. All right, so hey, this is BK Hobby. Today is my first live stream. Just wanted to show, just wanted to give it a try and see how it works. Did some testing and it seems like I should be doing okay with the live stream. So I'm kind of excited because I got these new PCBs from PCBWay today. Actually, only sent them out for production 2 weeks ago, and they already came back. So rather than make a whole new video about these, I kind of figured I'd tinker with them live and show you all the things I've done to it. Basically all the updates I've done to the board based on stuff that I've found out with version 1. So if you haven't seen these yet, I use these pretty much in all my sensors. Pretty early on, I found out that the NodeMCU doesn't really do well with, not this one, this is the 1.0, but the 0.9 version, the older one, doesn't do well with breadboards. So it doesn't fit on the breadboard basically. So I kind of wanted to create something that would allow me to tinker with it, test it, and then basically build it out into real, actual like things. For example, what you're seeing here is the NodeMCU LED controller that I've made videos about on my channel. So this is like a full, basically the board kind of holds everything together, NodeMCU and the connector, and it all goes into the enclosure that I designed in 3D print. And yeah, it goes in real easy, and then basically it gets covered up, and I put in my windows or underneath my kitchen cabinets and stuff like that. And then I also made these things, which are temperature and humidity sensors, Wi-Fi enabled. This one's actually, I have this one screwed in, so I'm not gonna open it up. But basically, you made a space for created space for a DHT22 sensor on the board, and a logic level shifter, which I'll talk about in a second. And then basically I put an OLED screen on these enclosures here, and that allows me to basically have a localized temperature controller or temperature sensor, temperature humidity sensor. I pull this data over Mosquito into OpenHab, and then from there I can graph temperatures in all the different rooms, adjust the vent fan registers, and try to maintain a level temperature, level climate between the different rooms. So yeah, and I kind of did some updates to it over time. One second. Cool. So I did add a level shifter to it originally, just for converting from 3.3 volts to 5 volts, and it just fits into here. I use these I2C level shifters that I found, I think on Adafruit at the time. But the problem with these is they're slow shifters. They're very they're not built for speed, and one of the applications of this board that I use them for is these WS2812 LED strips. And if I run it through this LED, or I'm sorry, if I run it through this logic level shifter, it fails miserably. It starts going crazy. You know, like there's flickers and all kinds of issues. So later on I found out that people have been using, or Adafruit actually, I think, posted the article on it, that people have been using these 74 HCT 125s or 245s. They're very fast level shifters, and people have been using them with WS2812 strips without any issues. So I decided to switch to that in this newer version. So that's one of the big changes. I also was using basically whatever GPI opens I was able to find at the time. So whatever was available, I wasn't really paying attention to what I was using. So I was definitely using some of the pins that have to be held low or high during boot up on these on the NodeMCU. So I've kind of switched away from doing that for the logic level shifter and for the external sensor signal, which I have here. Which, by the way, I'll show you. Yeah, right here. With with this one, as soon as I pull up the NodeMCU, I have an extension connector and basically a jumper. The jumper allows me to select 5-volt supply or 3.3-volt supply, and that goes to this external connector here that I created, and basically that's it has servo pin out, so I could use it to drive servos, but it also uses one of the GPIO pins to input signals. So I use those with these motion sensors, the PIR motion sensors, to turn on lights and stuff like that around the house. And then basically, I think that's it. I also had a high voltage line here, high voltage, the 5-volt, basically the output of the logic level shifter. I had that pinned out on the side here, so I could use it for like other channels. DHT22 over here, and then I had a resistor, which at the time I was using as a pull down resistor for the DHT22. I threw that in there, not knowing not realizing that the GPIO pins on the NodeMCU have built-in pull down or pull ups. So over time, I kind of realized that I had to make some changes to this board. I still use them. I still have a ton of them, and I use them, for myself for these sensors and for the LED controllers, because they're just fine. But I wanted to kind of create a new version and allow myself to fix some of the things that I knew were wrong with this board. So I got the I just got these today, basically. So one of the biggest things I did is I replaced the logic level shifter, obviously, with the 74A HCT 125. I replaced the resistor with a diode. This is a Schottky diode, and the reason for that is there's been issues reported with I forgot to mention one thing. I have the D0 pin tied to the reset pin, so you can use these boards with deep sleep, and the D0 will cycle during reboot, or D0 will output to the reset pin. The reset pin will no, it's the other way around. Reset pin will output to the D0 pin, and then that will wake up the NodeMCU after deep sleep. With that, I basically found out that there's an issue with basically the D0 output feeding back into the reset pin. So one of the things that, and preventing these things from going into flash mode and allowing you to flash them over USB. So with with this version of the board, I replaced that resistor that was kind of spare and useless with the Schottky diode, which prevents the feedback from D0 to the reset pin. So hopefully that fixes that issue. I still have basically a kind of like a high voltage pin out here, but I made this to be a I2C header now. So this is basically an I2C breakout. 5 volts, ground, and then clock and data, basically from GPIO 2 and 0, I think, D1 and D2 on the NodeMCU. Found that out from using these things with ESP Easy. So this sensor right now originally ran my code that I wrote specifically for these sensors, but ever since I've tried ESP Easy, ESP Easy has support for OLEDs now, so it's much nicer, much easier to deal with than writing your own code. So I basically stopped creating any more features in that code, and I basically switched to SPEasy. Yeah, so I'll try to build one of these up now and see if it works, because I haven't really tried that yet. So kind of live stream tinkering and hopefully not a colossal failure. So right. Get these in. All right. Then we're going to build in the jumper. Actually, start the jumper. Okay. And the actual external header. So same deal with this guy. I think need to use something to prop it up. Okay. Cool. All right. Yep, that works out pretty well. Then basically with this external sensor, I will take the cover, take the plastic off, and what I usually do is I take a servo connector, put it on fully, and then bend it over for 90 degree. And that's basically how I make that. I also need a jumper. There's one. And for this guy, I'll actually use the 5-volt line because I'm going to try first. I'm going to try it with the LEDs. Cool. And then I have these kind of pre-made here, so I'll use them. And I'll throw these in the 0.9 version NodeMCU slots.